Hello everyone, welcome to the 10th tutorial class on artificial intelligence. In the last class, we have discussed about the basic concept of fuzzy set, which is used to deal with the imprecise vagueness of any kind of information or data of real life. We have o- we have observed that fuzzy set can be expressed in term of ordered pair of element and its associative membership value. The membership value or membership function denote the degree of truthness or degree of belongingness or degree of membership for a particular element in a corresponding set. And we have also observed the different kind of features of a particular membership function like core, boundary, support, etc., etc. And we have also observed different kind of different types of membership function. Those are conventionally used in real life application of fuzzy logic. Now, in this class, we shall discuss about the different uh, operation those are associated with the fuzzy set, and after that we will observe the fuzzy proposition, and next we will discuss about the fuzzy rules followed by the fuzzy inference process. Okay, now let's move on. So first of all, fuzzy set operation. So uh, fuzzy's membership function can be described by mu a for a particular fuzzy set A. Okay. Now let's consider A is a fuzzy set and B is a fuzzy set, and the element of this fuzzy set are x1 comma zero point 0.5, where x1 is the element and zero point 0.5 is the corresponding membership function. Similarly, x2 comma zero point 0.1 and x3 comma zero point 0.4. Okay. And B is uh, similarly described like this way. Okay. Now, if we perform this operation A union B, so if we want to perform this kind of operation, so in that scenario, we can write that mu A union B x equal to maximum of mu A x comma mu B x. So for this example, particular example, if C equal to A union B, then obviously we can write that for particular element x1, you can see that for x1 corresponding maximum value corresponding value is zero point 0.5, and for x1 of B the corresponding membership value is zero point 0.2. So obviously maximum of zero point 0.5 and zero point 0.2 is zero point 0.5. Similarly, maximum of zero point 0.1 and zero point 0.3 is zero point 0.3. Maximum of zero point 0.4 and zero point 0.5 is zero point 0.5. So C is the new fuzzy set, which is the union of A and B fuzzy set, and that can be expressed like this way. So if we plot graphically, okay, so here you can see that this one is the mu A, described by the red color, and mu B is described by the faded green color. And if you perform the corresponding uh, union operation, so obviously cause output uh, membership function will be maximum of mu A. That will be max of mu A. That means uh, we want to get the maximum value of these two curve. That means this one maximum, this one maximum, this one maximum, and this one maximum. So obviously ultimately the output will be this one. Okay, so this one is the union. Similarly, intersection. So intersection of A B, that will be minimum of mu A x comma mu B x. So for same problem, if you observe the intersection, so that will be the minimum between zero point 0.5 and zero point 0.2, minimum of zero point 0.1 and zero point 0.3, and minimum of 0.4, 0.5. And that we for that purpose, C will become um, an ordered pair of fuzzy set x1 comma zero point 0.2, x2 comma zero point 0.1, and x3 comma zero point 0.4. And same for the same example, corresponding membership graph will become the minimum curve between mu A and mu B. So you can see that for up to this region, this one is the minimum, this one is the minimum, but next this portion is the minimum. Okay, so ultimately mu A intersection B will become like this. Okay, complement, as name the suggest, that means mu A AC x, that is nothing but 1 minus mu A x. Just subs substitute the value of zero point 0.5 from 1, and corresponding value is nothing but the complement of A, which is given by A suffix A, sorry, AC. Okay, so you can see that complement 1 minus zero point 0.5, zero point 0.5, 1 minus zero point 0.1, 0.9, 1 minus zero point 0.4, zero point 0.6. So mu A, we can, if red one, this one, so obviously if we uh, subtract it from 1, so obviously at this region 1 minus 1, that means 0. At the in this region it was linearly degrading, so obviously if we make substitute sorry, subtracted from it, so it will be gradually increasing. Okay, so we get ultimately output as mu complement, mu A. Okay, now there are others product, algebraic product can be done, a dot b. So in that scenario, just we need to multiply them, that means algebraic product a dot b equal to mu a x into mu b x. Okay, and the scalar product, if we multiply by alpha, which is a constant, so that will be just nothing but multiplication of mu a x with alpha, that is nothing but mu a alpha x. Now another important, very important operation, most, you can say that the most important operation is the Cartesian product A cross B. So A cross B, remember, A cross B, or Cartesian product between two fuzzy set A and B, that are not similar to the cross product of any kind of vector. Okay, so this is basically some kind of notation that is used to denote the Cartesian product between two fuzzy set, but the corresponding operation is completely different. Okay, so here mu A cross B, Cartesian product between A and B, comma xy, that means there are two set. Okay, consider two set, two fuzzy set A and B, and the corresponding element of B is y1, y2, y3, and corresponding element for A is x1, x2, x3, and x4. Okay, so now if we make Cartesian product between A and B, that is denoted by A cross B xy, so that is nothing but minimum of mu ax and mu vy. Okay, so whenever we want to write down the corresponding Cartesian product A cross B, so that can be expressed in time of matrix. So how can we represent that matrix? So like, for A1, we should write down the element columnize for in single column, and for B, uh, that means second fuzzy logic, the corresponding element, like that is y1, y2, and y3, we should write down along the um, horizontal axis. Okay, or horizontally of the matrix. Okay, now let's compare x1 y1. So this point is x1 y1. Okay, so x1 y1, what should we do? We need to find out the minimum value between x1 y1, sorry, membership value of x1 and y1. So minimum between point 2 and point 0.8, that is point 0.2. So point 0.2. Next one, x1 and y2. So x1 and y2. So minimum value between point 0.2 and point 0.6 is point 0.2. Similarly, x1, y3, that is point 0.3. Now coming to the second part, we need to compare between x2 and y1. So that is, you can find out that the minimum value between point 0.3 and point 0.8. So this is nothing but point 0.3, minimum between point 0.3 and point 0.8, that is point 0.3. So like this way it will be continued. So this one is the Cartesian product. So as we already told, this product or this operation is very much important. We later see that this has been used in describing the fuzzy relation. Okay, now let's move on. Another part is equality. That means if for all value of x of two fuzzy set A and B are same, then we can call it as equal product. Fuzzy set, for power of a fuzzy set A alpha, that means uh, just mu A alpha x equal to mu x to the power alpha. So that is power of a fuzzy set. And if alpha greater than 1, that is called as concentration, and if alpha less than 1, it will be called as the delay. So these are the other kind of arithmetic operation that will be performed, or those are performed, and that will express in term of this kind of expression. So mu a plus b x equal to mu a x plus mu b x minus mu a into mu b x. Difference, what is the difference between a and a minus b? So whenever we are trying to find out the difference between a and b, a fuzzy set and b fuzzy set, that will be a intersection of b complement. So mu a minus b x is nothing but a intersection of b complement x. Okay, now disjunctive sum a x or b, that is a complement union b, sorry, intersection b union a intersection b complements, sorry, complement of b. This one is a bounded sum, and for the bounded sum we should express mod of ax or bx. So that is denoted by minimum of 1 mu ax plus mu bx, and this is the bounded difference. That the notation are mod ax minus, sorry, x nor bx, and this one denoted by this symbol, and this will be given by max between 0 mu x plus mu bx minus 1. Okay, now let's see a real life example to find out the impact of the corresponding arithmetic operation. Like consider two phi set A and B with membership function mu ax and mu bx, and respectively defined as below. Okay, so here define the cold climate, and the corresponding membership function is given by the red colored. That means up to 5, value of 5, the value is 1, and then it is sharply decreasing up to 25. Okay, and this one is the hot climate. Okay, that means if we plot temperature in x-axis and mu corresponding membership function along the y-axis, then the hot defined as the that from minus 15 to 5 corresponding value is 0, and from 5 to 25 it is gradually increasing, and after 25 the value of value of mu b is 1. So you can see that at this region, this one is this portion describing the maximum very hot weather. This one is a very cold area. Okay, and okay, now next, where x being the universe of discourse, representing the entire range of temperature. So here the entire range of temperature is given by from minus 15 degrees Celsius to 50 degrees Celsius. Let's find. Now, the problem is we need to find out the fuzzy set that represent not cold climate. So what do we have? We have cold climate and hot climate, but the question arises not cold climate. Find out the corresponding membership function for this, and not hot. Sorry, this one is the hot, not hot climate. Okay, and extreme climate, pleasant climate. Okay, find out next. So not cold climate. How can you define that? As mu a define the cold climate. So obviously, if we make complement of cold, that will define, that will nothing but not cold. So a complement is nothing but 1 minus mu x. So obviously, the value corresponding 1 minus mu x will define, or will say, the not cold climates. As similarly, not hot climate is given by 1 minus mu bx. Okay, now extreme climate. So what is the extreme climate? We want to find out. So if you want to find out the extreme climate, that means too much hot or too much cold is obviously extreme cold. So we want to find out the region where the uh, value of mu a and mu a is maximum. Okay, so if we make maximum or union of a and b, so that is defined by the extreme climate. So a union b, that is max of mu a x comma mu b b x, that is denote the extreme climate. So you can see that if we make the union between a and b, so obviously we have to find out the maximum area, that means sorry, maximum value of mu and both mu and mu b. So this will be given by this. So extreme climate is given by this. Okay, Now, pleasant climate, as the name suggests, where the not too much hot or not too much cold, that is the pleasant climate. So how can we find that corresponding membership function? So where we want to find out the minimum value of temperature, sorry, minimum value of both A and B. Okay, so in that case, we will find the intersection between A and B. So membership mu A intersection B x, that is minimum of mu A x comma mu B x, that is the pleasant climate. So obviously you can find that if we make the intersection between mu A and mu B, so you will observe the minimum value. So obviously you can see that this area. Okay, so we will find this kind of membership function, that is denote the present climate. So from 5 to 25, that one is the present climate. Fine. So like this one is the real life example that denote the defined membership operation. Now fuzzy relationship. Now fuzzy relation is a fuzzy set defined on the Cartesian product of the crisp set x1, x2, and xn. Uh, so consider an example like if I have typhoid, so obviously the main symptom will be main symptom will be high temperature. Okay, and if I have cold, so obviously my temperature will not so high, but I have running nose. That means there is some kind of relationship between two fuzzy set. Okay. Oh, so that is denoted by the fuzzy relation. So fuzzy relation is a fuzzy set defined by the Cartesian product of two crisp set x1, x2, xn. Hmm. So here n tuple x1, x2, xn may have the varying degree of membership with a different relationship, and the corresponding membership values denote the strength of the relationship between the tuples. Let's understand it by some kind of example. So consider X is a set where given by typhoid, viral, cold, and Y is another set um, that is given by running nose, high temperature, and severing. So obviously there is some kind of relationship between two case set. Okay, so if you want to find out this kind of relation between X and Y, and that should be expressed in term of um, fuzzy relationship, that is expressed in terms of Cartesian product. So you can see that and Cartesian product denote the strength between or the strength of the relationship between the tuples. That means point 1, this value denote actually the strengthness between or the relationship between typhoid and running nose. That means if I have typhoid, the certainty of running nose is point 0.1. That means I have uh, less chance or less certainty to be running nose. But if I have cold, we can see that corresponding membership value is 0.9. That means obviously must have running nose. Okay, and if I have cold, you can see that high temperature is corresponding value membership value is zero point 0.4, and severing corresponding value is zero point 0.6. So like this way. So we should express in matrix way and or Cartesian product way. Along vertically we should plot x, and horizontally we should plot the element corresponding to y, and the corresponding relation corresponding membership value between these two element or two tuples denote the strength. Okay, that is the fuzzy relationship. So suppose let's describe in term of mathematics. So A is a fuzzy set on the universe of discourse x with mu a x, so that x belongs to capital X, and B is a fuzzy set on the universe of discourse y with mu b y, so that small y belongs to capital Y. Okay, now relationship that is expressed in term of capital R equal to A Cartesian product of B, okay, A cross B, so that it is subset of x comma y, sorry, x cross y. So R is a R is the fuzzy relationship, and R has a membership function given by mu r x comma y or mu a cross b x y, and we already know the Cartesian product between two fuzzy set A and B for the element x and y given by minimum of mu x into mu y, and that those are expressed in term of um, matrix format way. So here you can see that the for A, for example, for A is a fuzzy set and it express A1.2 comma A2.7 and A3.4 like this way, and B has two element with two membership, so B1 comma point 0.5 comma B2 comma point 0.6. So the element for the A set, A fuzzy set, the elements are uh, given along the vertical axis, and B1 and B2 are given along horizontal axis horizontally. So now we'll uh, make minimum value between mu yeah, between corresponding membership value between mu a x1, sorry, mu a a1 and mu a b1. Okay, like this way. So minimum between zero point 0.2 and zero point 0.5 is zero point 0.2, minimum between zero point 0.2 and zero point 0.6 is zero point 0.2, minimum between zero point 0.7 and zero point 0.5 is zero point 0.5, minimum between zero point 0.7 and zero point 0.6 is zero point 0.6, minimum between zero point 0.4 and zero point 0.5 is zero point 0.4, zero point 0.4, minimum between zero point 0.4 and zero point 0.6 is like this, zero point 0.4. So this one denote the actually fuzzy relationship. Now there are others kind of operation, those can be performed on fuzzy relationship. Okay, so similarly as the fuzzy set, the relation there are union, intersection, complement. So mu r union s a comma b given by maximum of mu r a comma b and mu s a comma b. Intersection mu r intersection a comma b, that is mean mu a r comma a b and mu s comma a b. Now complement, similarly if we uh, make difference between from one, that will be given by the complement of the corresponding members, corresponding relationship. And composition, at this can be given by tr dot s. Okay, and it will be given by like this way: max y belongs to y, minimum of mu r x comma y and mu s y comma z. Okay, and all these operation can be easily implemented for all kind of fuzzy logic operation or fuzzy logic example. Now next one is the fuzzy proposition. So proposition, that means a sentence that denote the some kind of information or judgment. Okay, and the basic assumption for any kind of proposition for the crisp logic is that every proposition is either true or false. Okay, like I am tall or not, he is tall or not, like it is true or false. Okay, so the classical proposition, classical crisp logic proposition should have two valued logic, but it can be extended up to multi-valued logic, like one or two or three. But the number of value is finite. Okay. Now, the fundamental difference between crisp, that is classical proposition, and the fuzzy proposition is in the range of their truth values. That means it can truth values means what is the corresponding output. That means either it is true or false. So it can take either one or zero. But in case of fuzzy proposition, so its truth value can be can be changed or can be varied from the range of 1 and 0. Okay, so while each classical proposition is required to be either true or false, the truth or falsity of fuzzy proposition is a matter of degree, and that is similar to the membership value. Okay, so the degree of truth for each proposition is expressed by a value in the interval of 0 comma 1 0 1, both inclusive. That means for the fuzzy proposition, the degree of truth is, or truth value is given in between 0 and 1. Okay, let's define it with the help of mathematics, or explain it with the help of example. Suppose capital X is the universe of discourse of 5%. So you can say, and 5% intelligent of X that belongs to capital X is a fuzzy set that is defined by intelligent x1 comma zero point 0.3, x2 comma zero point 0.4, x3 comma zero point 0.1, x4 is zero point 0.6, and x5 is zero point 0.9. So this is a proposition. So proposition consists of two parts. One is subjective and another is predicate. Subject and another is predicate. So like uh, if we can say that X is intelligent. So X is subject, intelligent is the predicate. So fuzzy proposition can be described in term of like P colon X is intelligent, and the intelligent is expressed in term of a fuzzy logic. So that is fuzzy proposition. Okay. So predicate in term of fuzzy set. So P colon V is F, where V is an element that takes value V from some universal set of capital V, and F is a fuzzy set on capital V that represent a fuzzy predicate. In other words, given a predicate element V, this element belongs to fuzzy F with membership grade mu F V. So let's explain with the graphical representation. Like you can say that for this corresponding uh, for a given value of V. Okay, so this is the corresponding membership graph. That means we plot x-axis variable V, and along y-axis we plot the corresponding membership value. So for a given value V of variable capital V, the proposition P TP denotes the degree of truth of proposition P. That means we should find out the corresponding membership value at this point. That means we should draw a vertical line, and the intersect, if we draw a horizontal line that intersect the corresponding membership function. So this point denote the TP. Okay, that means truth of proposition. That is nothing but the membership value. Okay. So in case of fuzzy proposition, truth of proposition is nothing but membership value. So that is another physical significance of membership function. So in case of crisp proposition, the truth of proposition will be either 1 or 0. But in case of fuzzy proposition, it will be either in between 1 and 0. It can take any value depending on the membership function. So this one is the several notation or for different operation like not, or, and, implication, equality, and those can be given by like this. Not is of given by 1 minus TP, or is given by max TP TQ, and is minimum TP TQ. Implication is given by max 1 minus TP comma TQ. Equality is given by 1 minus mod TP minus TQ. Like this way we can define several operation on fuzzy proposition. Now coming to the fuzzy rules. Okay, fuzzy rules, it is also known as the fuzzy implication, or fuzzy if then rule, or fuzzy conditional statement. So basically the formal uh, structure of fuzzy rule is like if x is a then y is b, where a and b are two linguistic variable defined by the fuzzy set, and x and y are corresponding element of the universe of discourse x and y. Okay, so a and b are two fuzzy set, x and y are the elements. Okay, and we often called x is a is that means the step portion x is a, that is called the antecedent or premises, and why a is b, it is called the consequence or the conclusion. Okay, so what is the significance of the fuzzy rule in the uh, fuzzy system of real life? Basically all fuzzy systems are depending on this some kind of fuzzy rules. That means consider a real life scenario. Suppose you are driving a motorcycle. Okay, so suppose your speed can be varied. Okay, and whenever you try to make some kind of you are driving in along the curvature, that means you are try to taking turn. So in that case you need to keep in mind the different fact, like what is your velocity, what are the curvature of the turning, and what are the weightage of your passenger. Suppose there are 2 or 3 persons, there are another 4 passengers in your bike. So all the uh, facts it should be considered. Like if the velocity is slow and turn is small and there is no co-passenger, so you don't need to give any kind of brake, or you need to push the speed breaker very small. Okay, so these are the some kind of real life application, real life example of fuzzy rule. So it should be given for a particular fuzzy system. Okay, like for example, if pressure is high, temperature is low. If mango is yellow, then mango is sweet, else mango is sour. If the road is good, then we can then drive is smooth, and else traffic is high. Okay, so fuzzy implication or fuzzy rule can be denoted by R colon A implied to B. Okay, so in essence, a fuzzy rule or fuzzy implication defined by a binary fuzzy relation R on the product of A cross B. Okay, so it represent remember it represent a binary fuzzy relation on the product of A cross B. Fine. Now let's see an example. So suppose P and T are two universe of discourse representing pressure and temperature respectively, and it has given by the corresponding value element like 1 2 3 4, and T are temperature 14 15 20 25 30 35 40 45 and 50. So let the linguistic variable high temperature. So we define high temperature using fuzzy set T high and low pressure by P low. So we define two fuzzy set. So first fuzzy set is given by like this. So for 20 comma point 0.2, 25 comma point 0.4, 30 comma point 0.6. So for 10 and 15, we assume the corresponding membership value is 0 like this. So high temperature like this. So you can see that 40.7, 45.8, 50.8. So obviously, when the temperature is rising, corresponding membership value is gradually high. So obviously, denote the membership function. Sorry, it denote the fuzzy set for the corresponding temperature high. And this one is the P low. That means for low pressure, corresponding membership value will be high, like 1.8, 2.8, 3.6, 4.4. So as the temperature decrease, as the pressure increase, corresponding membership value decrease. Okay, because it define the mm, low pressure. Okay, now let's see. Then the fuzzy, then the fuzzy implication, if temperature is high and pressure is low, will be given by this. So just simply plot uh, element, corresponding element 1 2 3 4 of pressure low, and other those elements that exist in high temperature like 25 24 30 35 40 45 50. As the first 10 and 15 are not mentioning here, so we don't need to bother about during in the Cartesian product. So like this. Okay, so rest of is same, rest of is similar. So you can see that for fuzzy set sorry, so what is the certainty when the when the temperature is 20 and the pressure become 1? So you can see that when the temperature is low, pressure is also low. But here you can see that when the pressure is when the temperature is high, pressure is low. Okay, like this way. And when the temperature is high, pressure is high, and the certainty in between them is 0.5. So if temperature is 40, then what about the low pressure? So you can see that just move to the 40 row, row corresponding to 40 temperature, 40 degree temperature. So you can see that the pressure for low pressure of 1, corresponding certainty is 0.7, for pressure 2, 0.7, 0.6, and point like this. And there are several operations those can be implemented on the fuzzy relation, or fuzzy rule, like A cross B, and it is given by integration of x cross y mu x into mu by, but it is known as the T norm operator. And there are other there is another different operator like minimum T mean a comma b, that is minimum a comma b, that is the intersection, algebraic product, multiplication of a and b, bounded product, drastic product, and all the rule are given here. So you should remember all those things. Okay. Now another thing, mean operator and product operator. Mean operator means Rm equal to a cross b, and that can be given by a intersection b. So integration x cross y mu x intersection a sorry, mu x intersection mu b by, or you can say that, and this one is the AND operation. Sorry, this one is the AND for the Fuzzy rule. Okay, this one called the Mamdani rule. This one is the Larson rule. Now coming to the next point, Fuzzy inference. So similar concept can be applied, that fuzzy logic. In case of fuzzy logic, uh, fuzzy rule. Fuzzy logic. Sorry, yeah. A fuzzy rule can be inferred. That means how can we infer a fuzzy rule? Okay. Uh, Sorry. So fuzzy inference. That means if some kind of rules are given provided. Okay. So for a particular condition, what will be the other output? So, okay. So this one is the fuzzy rule. There are two types of fuzzy inference system: generalized modulus ponens (GMP) and GMT. So here it is given, if x is a, then y is b. Then when x is a and output is y is x is a complement, obviously y is b complement. Similarly, if x is a, then y is b. It has been given. Then if y is b complement, then obviously x is a complement. Okay. So sorry. So another thing, here A, B, A dash and B dash are the fuzzy set. To compute the corresponding membership function A dash and B dash, the maximum composition of the fuzzy set B dash and A dash can be implemented. And for so B dash can be given by this A dash into R into XY, and A dash equal to B R into XY. And mu B Y and mu A X can be calculated from this using formula. So coming to the conclusion part, so in this class we have observed different kind of arithmetic operation on fuzzy set. Then we have observed fuzzy proposition, fuzzy rules, and fuzzy inference. So these are the references.